Hello everyone. Okay, so in this video we are looking at the empirical rule and normal distribution. So let's get crack-a-lackin'. So first of all, to know about the empirical rule, we need to know what the normal distribution is. So recall here, the normal distribution data is said to be normally distributed if it's distributed in a bell shape, right? So data can be distributed in different ways. So here we go. This data is more spread to the left. This is left skewed. This data is more spread out on the right. So this is right skewed. And this one's just all over the place. So there's not really much spread to it. But if a data looks like a bell, right? It looks like this, a bell shape. Recall, like, remember bells look like this. That's why it's called a bell shape, right? Remember bell, like ring a ding 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 ding. Right. If my data is shaped like this, then we can say my data is normally distributed. Now, if my data is normally distributed, that means there's a few little fun little things we can do with my normally distributed data, right? And one of the fun little things we can do with my normally distributed data is use the empirical rule. So, examples of normally distributed data. It's like heights of people are normally distributed. The blood pressure is normally distributed. Marks on a test are normally distributed. And that makes sense, right? Because if I was looking at data here and pretend these are people's heights, yeah? Well, it would make sense not a lot of people would be really small. Say it's the heights of adults, right? It would make a lot of sense that not a lot of people are really small. It would make sense not a lot of people are really tall either. Like, there'd be few people who are really tall, few people are really small, but that's not the norm. But a lot of my data here is within the average of my data. Like, a lot of my data does tend towards the middle. So, properties of the normal distribution. So if data is said to be normally distributed, then the mean equals the median, which equals the mode. So all of my three averages are equal, and there is symmetry around the mean, right? So that means 50% of values lie above the mean, 50% of my values lie below the mean. So that means it's symmetrical. That's what symmetry means. It just means symmetrical. So let's look at my empirical rule. The empirical rule, sometimes called the 68, 95, 99.7 rule. Really rolls off the tongue, doesn't it? It states that for a given data set, if it's normally distributed, right? This is really important. You have to learn this off for your Leaving Cert, as it's not in your log tables. 68% of my data falls within one standard deviation of the mean. 95% of my data falls within two standard deviations of the mean, and 99.7% of my data falls within three standard deviations of the mean. So what does that mean? Well, that just means if I have my mean value, right, in the middle, and I add one standard deviation to the right, and then I subtract one standard deviation, I should get a range of data with 60% of my data lies. So let's just have a look at the problem here, right? Because it might help you make more sense of it. So the marks out of 100 in an examination are normally distributed. The mean mark is 60 and the standard deviation is 6 marks. Work out the mark that is 2 standard deviations above the mean. So I want to find out the standard deviation. The mark that's 2 standard deviations above the mean. So that is going to be 60 plus 2 times 6. Because my standard deviation here is 6. And then my mean is 60. So 60 plus 2 times 6 is going to be equal to 72. So 72 marks are 2 standard deviations above the mean. Part 2. What percentage of the marks lie between 48 and 72 marks? So we want to find out what percentage of people got between 48 and 72 marks. So if we just look at this, so we know the data is normally distributed, so I have my little normal distribution here. I know my mean is 60 and that is in the middle. I notice here, well, 72, that is 2 standard deviations above the mean. And then 48, 48, if we recognize, is 2 standard deviations below the mean, because that is equal to 60 minus 2 times 6. So 60 minus 12, which is 48. So 48 lies 2 standard deviations below the mean. So we subtracted 2 standard deviations. And then 48 marks is here. Now, what percentage of marks lie between 48 and 72? Well, using the empirical rule, I know for a fact this area here between the 2 points is going to be equal to 95%. It's equal to 95% because the data 95% because the data lies within 2 standard deviations. IV, what percentage of the mark lie between 60 and 72? Right, so I want to find out now. Here's my mean. So my mean is the middle value right here. And then here it says 72. This is 2 standard deviations above the mean. I want to find this area right here. Now, I know for a fact, I love when it does this. Oh, where are we now? Sorry. Right, I know for a fact, right? So, this is my mean in the middle here. 50% of my data lies over this side, right? But what is this little orange region here? Well, I know 95%. So if we go back up to my diagram here, I know 95% of my data, right? I know 95% of my data lies here. But, right, using my symmetrical property of the normal distribution, remember I said it's perfectly symmetrical, right? Down the middle. This whole total is 95. That means to the left of it, it is going to be 42.5%. And here's going to be 42.5%. So I know in that trapped little region there, 2 standard deviations above the mean, the answer is going to be 42.5%. So 42.5% of my data got between 60 and 70 marks. Right, IV, let's do this part here. If 1,000 students took the examination, how many students scored less than 54 marks? So, draw out my diagram here. Right, so there's my middle, 60 is my mean. I'm looking at 54, so 54 is down here. Now, if I recognize the 54, that is going to be, so we're looking for who got less than 54 marks. Actually, let me bring that a little bit closer. 54. Right, what do we recognize now, the relationship between 54 and 60? Well, we should be able to recognize that that is 1 standard deviation below the mean. That's 1 standard deviation below the mean. Now, we know our empirical rule states 68% of my data lies between 1 standard deviation. So 1 standard deviation above and below the mean. But it's only below the mean here. And then so using our symmetrical property, we know that this area is going to equal 34%. But that's not what they're asking me here, is it? They're asking me to find, ding, 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 this purple region right here. So, how can I find this? right? So I'll put 54 here and 60. How can I find this purple region? Well, I know for a fact that this entire left side of my normal distribution is equal to 50%. So this entire thing is 50%. I already know what this part is. I already know what this is. So I just need to take that away from 50 to get the purple part. So the purple part is going to be 50% minus 34%, which is equal to 16%. So 16% of people got below 54 marks in their tests. Right. Let's do some more examples here. Right. The height of plants in a certain garden are normally distributed with a mean of 31.9 inches and a standard deviation of 5.3 inches. Use the empirical rule to estimate what percent of plants are less than 37.2 inches tall. So less than 37.2. So let's draw it out. Right, there's my middle, always draw it out, that's 31.9. Then 37.2 is going to be up here. What do we recognize about 37.2 and 39.1? Well, let's look at my standard deviation here, right? Because obviously there has to be some sort of standard deviation away from the mean. So let's test that out. Let's test that theory out. So 31.9 plus 1 standard deviation of 5.3 is equal to 37.2. Would you look at that? Right? So that means, actually, let me make that a little bit closer. So that means this section of the data is 1 standard deviation above the mean. Right, so 1 standard deviation above the mean, 60, 95, 99.5. So 68% of my data lies within 1 standard deviation of the mean. But remember, that's 1 above and below. This is only above. So this area is going to equal 34%. But what area am I looking for here? I'm looking for the plants that are, the percentage of plants that are less than 37.2. So I'm looking for all of this. Well, again, like I said, right, previously, I know between 31.9 and 37.2, 34% of my data lies. What percentage of my data lies below 31.9? But remember, this is my mean, and my data is symmetrical around my mean. So that means this is equal to 50%, if you can see it, right? So therefore, it's 50 plus 34, which is equal to 84%. So 84% of my data lies below 37.2 inches. Right, another one. In a factory, the weight of a concrete poured into a mold by a machine follows a normal distribution with a mean of 1,150 pounds and a standard deviation of 22 pounds. Approximately 95% of the molds filled by this machine will hold weights in what interval? So it's asking me for the range of values, right, for 95% of my data, or 95% of my molds. So 95% of my data, plus or minus 2 standard deviations, right? So that is what we're looking for here. Right. So my mean is 1,150 pounds, and my standard deviation is 22 pounds. So $1,150. Add 2 standard deviations. So 2 times 22. That's going to be 1,194. And then below that, minus 2 standard deviations. 1,106. So 95% of molds will lie between 1,106 and 1,194 pounds. Right? And finally, the last question here, I think. Yes, it is. The last question here. The ages of golfers are normally distributed with a mean age of 38 and a standard deviation of 4. Find the proportion of golfers who are older than 42. So, again, always draw a sketch. So remember, I see the words, right? Normally distributed, right? And a standard deviation. So I'm probably going to use my empirical rule. So my mean is 38. 42. Well, 38 plus the standard deviation, so 38 plus my standard deviation of 4 is equal to 42. So that means this data lies one standard deviation above the mean. That means this is all equal to 34%. So between 34% of golfers are between 38 and 42 years of age. Now, but we are looking for the golfers who are older than 42. So we're looking for the golfers who are in this region right here. What percentage of golfers lie there? Well, as I said, we have to have a bit of puzzle in here because the entire right-hand side is going to be equal to 50%. And if the entire right-hand side is equal to 50%, that means the little purple bit is going to equal to 50% minus 34%, which is equal to 16%. So 16% of my data is, or 16% of golfers are older than 42. Right, so I hope this video was some help. That's my video on empirical rule, and I'll catch you guys later. Bye.